Hey, what's up, Chem Peeps? We're gonna do one more vid here. We calculate the pH change in a buffer solution. What is the pH of the final solution after the addition of 125 mils of 0.500 molar sodium hydroxide to 250 mils of a solution that is 0.500 molar acetic acid and 0.450 molar sodium acetate? Ka for acetic acid is 1.8 times 10 to the minus 5. First, notice that I've got my equation to represent this buffer system, my acetic acid acetate ion buffer system. Okay, so first thing I'm going to do is I'm going to think about how many moles of my invader, and this time a strong base, I have. 0.0625 moles, just using my molarity equation. Next, I'm going to think about how many moles of my weak acid I have. Once again, using my molarity equation. And then finally, I'm going to calculate the number of moles of my conjugate base. Again, molarity equation. Again, think about this very important formula for any time you're calculating pH of a buffer system. And think about the reaction that's going to occur upon the addition of that strong base. In your buffer system, our weak acid is going to sacrifice itself, neutralize that added base, that added strong base, and help protect the pH. But in so doing, it's going to make some more conjugate base. Okay, and recognize then, if we plug in the Ka for acetic acid that we're given in the problem, that some of our weak acid sacrificed itself, but in the process made additional conjugate base. So notice here that we have subtracted the amount of strong base that was added from the weak acid and added it to the amount of conjugate base that we originally had in our buffer system. So just plug this into your calculator to solve for hydronium ion concentration, 7.7 times 10 to the minus 6 molar. Using your pH equation, which is equal to the negative log of your hydronium ion concentration, you can determine the pH of your buffer system to now be 5.11.
Parentheses 0.138 minus 0.0625 close parentheses enter. New parentheses 0.113 plus 0.0625 close parentheses enter. 0.0755 divided by second answer times new parentheses 1.8 second e negative 5 close parentheses enter. Negative log second answer enter.
So again, I cannot emphasize this enough. No matter what type of pH calculation you're doing with a buffer problem, always come back to this equation. Always come back to this equation. Always, if you're trying to just determine the pH of a buffer, simply use this, you're done. If you're trying to determine the pH change in a buffer, simply think about whether what was added was a strong acid or strong base, and which component of your buffer would get used up, would sacrifice itself to neutralize that added strong acid or strong base, and which component of your buffer system would get made in the process. And lastly, recognize that even though your Ka expression relates concentrations, it's really about ratios of numbers of moles. So you could go back to concentrations, right? If you've added 125 mils, you could think about what these concentrations would be by taking these number of moles out of not 125 milliliters, but 125 plus 250 mils. You would get the same answer, but recognize that the volume would cancel out anyway. All right, we'll do lots of practice in this in class. Have a fantastic day.